Logarithms and logarithmic equations is the topic of the day. So what's a logarithm? Well, a logarithm basically is just an exponent. We need them when we solve exponential equations sometimes because we can't always take an exponential equation and write both sides in the same base. For example, if I have 2 to the third power equals 2 to the x, then we learned a couple of days ago that because our bases are the same, our exponents have to be equal to each other. And we also learned that if the bases aren't the same, if I have 2 to the third equals 16 to the 4x, I can take that equation and I can rewrite my 16 as 2 to the fourth power. And then I can make an equation out of my exponents because my bases are the same and I can ignore them. Well, what happens when the bases are not the same? If I have 2 to the third power equals 3 to the x, there's absolutely no way for me to write the number 3 in base 2. So I need a different way to do this. And that's where logarithms come in. So a logarithm it has 3 parts to it. There's the word log, there's the base, so it's a little subscript. If you don't see the subscript, it's understood to be base 10. Then there's the answer, equals, and then it has a value. So every logarithm has a value. This logarithm has a value of 4. Because basically, when I'm asking what the value of log base 2 of 16 is, it's asking for what's the exponent on the base. So 4 is the exponent. This is my base. So if you think about that, if I took my base of 2 and I raised it to my fourth power, what's it give you? Well, 16. So logarithm, the value of a logarithm really is just the exponent that you would need on the base. So log base 3 of 9, what do I have to raise 3 to get the number 9? 2. So log base 3 of 9 equals 2. So that's why they say a logarithm is just an exponent. Okay, so hopefully you printed off your notes. Let's take a look at our notes here. So we can go back and forth between exponential form and logarithmic form. So your exponential form, you have your base, you have your exponent, and then you have your answer. So if I want to go back and forth between logarithmic form and exponential form, when I go into logarithmic form, I have to write down the word log. Oops, lost my pen. So log, and then my base, so this would be log base b of y equals x. Okay, so you can kind of see where things go here. So my base is right here. My b is my base, and my b is, let me just point them out here. It's the base over here, so it's a thing raised to the power. It becomes a little subscript on your log. And then the exponent, my x, it becomes the thing that's isolated on the other side. And then the answer from your exponential form is what you're taking the log of, is what they say. Okay, so b to the x equals y, and log base b of y equals x. Those two forms go, you can bounce back and forth. Okay, so let's just look at a couple and we'll practice bouncing back and forth between the two forms here. So if I have all these logarithms, I want to rewrite those into exponential form. So you have to first identify the base. So this is log base 3 of 9 equals x. So this just turns into 3 to the x equals 9. Because you take your base, and then this thing that's isolated on the other side here, this is your exponent. Okay, sorry, that's a little sloppy. Okay, and then in this next one here, take my base 2 to the x equals 8. Hey, why don't you guys pause the video, try to fill in C through F, and come back and see if you got them right. Hopefully you tried these on your own. Here are your answers. For letter C, 3 to the x equals 27. For letter D, 4 to the third equals x. Letter E is 2 to the fifth equals y. And letter F is 3 to the second power equals y. And we're not solving those right now, we're just rewriting them from logarithmic form into exponential form. Okay, so let's go the other way now. Write the following in logarithmic form. Okay, so you want to identify your base. So you're going to write down the word log first, log. And then your base is the number that has the exponent on it. So for letter G, my base is 3. So you're going to have a little subscript of 3. And then the exponent is going to be the thing that's isolated on the other side of the equal sign. So this is log base 3 of y equals 4. So the exponent is all by itself. So for letter H, this would be log base 3 of 27 equals my exponent, which is x. All right, pause the video, please, and try the next 4. Okay, hopefully you tried those, and here are your answers. Letter I, log base 4 of m equals 2. Log base 3 of y equals 5. Log base x of 32 equals 5. And log base 4 of 64 equals x. Okay, so we have to be able to bounce back and forth in between those two forms. We're going to learn how to solve logarithmic equations. Sometimes you can solve them when they're written as logs, and other times you have to put them into exponential equations to solve them. So for exponential equations and logarithmic equations, if you can't solve it the way it's been presented to you, you have to flip it over to the other form. So if I have an exponential equation and I cannot write both sides in the same base, I have to switch over to logs. And that's how we solve those types of equations. So we have to be able to bounce back and forth depending on the situation you're in. Okay, here are a couple that we're just going to rewrite and solve. Okay, so these are all your logarithmic equations. So we're going to put those into exponential equations. So rewrite it first. So log base 3 of x equals 4 is going to turn into 3 to the 4th equals x. And if it says solve, then you want to go ahead and simplify as much as you can. So 3 to the 4th is 81. So x is 81. Okay, for letter N, we're going to write it as m to the 4th equals 81. Okay, when we go to solve this one, we're going to have to take the 4th root of both sides. Because we're going to undo that power of 4. So when we take the 4th root of both sides, then m is going to equal the 4th root of 81, which is just 3. Technically, it's plus or minus 3. But we cannot have a negative base. Okay, so your final answer is just x equals 3. You'll never have a negative base. Your bases are always going to be positive. So if you do have to undo a power of 4 or a power of 2 or any even power by taking the root, answers are going to be plus or minus, but if it's the base. So like in letter M or N, the M was the base in the original equation. So the bases are always going to be positive. So we only use the positive. All right. So letter O, x to the third power. Oops. A second. X to the third power equals 1,000. So for this one, we're going to just take the cube root of both sides. When we take a cube root, we don't have to worry about that plus or minus. So the cube root of 1,000 is just 10. Okay, pause the video, please. Try the next three. Okay, so let's check and see if you got them right. Exponential form, 2 to the 5th equals x over 2. And then we want to go ahead and solve this. 2 to the 5th is 32. We want to go ahead and multiply both sides by 2. So we can cancel out the denominator. So in 2 times 32, that's just going to give me that dark green. 2 times 32 is 64. So x is 64. 3 to the 5th equals y. So 3 to the 5th power is 243. So y equals 243. And then lastly, 2 to the 5th equals 4x. And then we want to go ahead and solve that. 2 to the 5th is 32 equals 4x divided by 4. So x equals 8. So hopefully you got those right. Not too bad. Okay, so those are your real basic logarithmic expressions and equations. So then when we go to solving logarithmic equations, so we have two different situations to start with. We have case 1 where you have just one log in the equation. So what you're going to do is you're going to switch it over to exponential form and then you just solve it like we've done in the previous page. So when you look at all these examples here, I just see a log on the left and I see a number on the right. So if you don't have a log on both sides, just a log on one side, we're going to go ahead and just put this in exponential form. Okay, so 36 to the 3 halves. 36 to the 3 halves equals x. Okay, so now this is one of those equations we've done before. We have a rational exponent. So recall that when you have a fraction in your exponent, that's your power on top and then your root on the bottom. So this is the square root of 36 to the third power. So if I take the square root of 36, that's 6 to the third power. And 6 to the third power is 216. So once you put it in exponential form, you'll see any type of equation. These are all going to result in rational exponents. So this second one, 9 to the 3 halves equals x. So 9 to the 3 halves equals x. So again, it's the power over the root. So it's the square root of 9 to the third power equals x. Square root of 9 is 3 to the third. So then my x is 27. Try number 3, please. Pause your video and try number 3. So for number 3, you should have gotten 16 to the 5 halves equals x. Power over the root. So it's the square root of 16 to the 5th power equals x. The square root of 16 is going to give me 8. No, it's not. It's 4. Sorry about that. The square root of 16 is 4 to the 5th power. And then if you take 4 to the 5th power, you should get 1024. Okay. So those are, when you have your case 1, you just 1 log on in your equation. Case 2, this is a little bit different. We have 1 log on each side. Well, for these, it's kind of the same concept as your exponential equations. If both sides are the same base, then all you have to do is cancel the logs off and solve the resulting equation. So here I have a log base 2 equal to a log base 2. So these are the same base. So you can just cross the logs off and solve the equation that you get from that. So we have x squared minus 4 equals 3x. You're left with a quadratic, so you want to make sure you solve it properly. You want to set it equal to 0 and factor it. Okay, and then you want to always check for extraneous solutions. So our extraneous solutions are solutions that we get by properly solving the equation, but then when we go to plug them back in, they don't actually work. So a couple things that can't happen for logarithmic equations: your base can't be negative. And also, you cannot take the log of a negative number or 0. So make yourself a note. Of a negative number or 0. So you want to go back and check if when I plug in my 4 right here, I just want to make sure this little piece of it stays a positive number. And then I also want to plug it in over here and make sure that this piece of it is a positive number. So if I put it in right here, 4 squared minus 4, 16 minus 4 is still positive, so we're good. So the 4 works on that side. If you look at the other side, 3x, if I plug a 4 in right there, 3 times 4 is 12, and that's positive, so our 4 is good. Negative 1, if you put a negative 1 in, negative 1 squared is positive 1. Positive 1 minus 4 is going to give me a negative 3. So, and also if you plug it in over here, 3 times negative 1, that gives you a negative 3. So negative 1 is an extraneous solution. So we're going to cross that one off because that's an extraneous solution. So you always want to go back and check. Let's do another one. So for this one here, number 5, I have log base 3 equals log base 3. So logs have the same base. I'm going to just cancel them off and solve my equation. Another quadratic, so set it equal to 0. I don't know what's happening. I have a new stylus. Bear with me. Okay, let's start that again. Okay, so x squared minus 15 equals 2x. So x squared minus 2x minus 15 equals 0. So you just want to set it equal to 0 and solve it. Go ahead and factor it. So we need two numbers that multiply to negative 15 but add to negative 2. So we'll go with x minus 5 and x plus 3. X equals 5, x equals negative 3. Then go ahead and plug in and make sure that just this little section right here stays positive and this section stays positive. But I can already see if I plug a negative 3 in right here for my 2x, I'm going to get a negative 6. So my negative 3 is extraneous. I'm not going to use that one. If I plug in the 5 squared minus 15, that's still a positive number. And 2 times 5, that's also a positive number. So your only solution for this one is x equals 5. Okay, try number 6. Okay, so number 6, my bases are the same. I can cross them off, set my equation equal. X squared minus 6x equals negative 8. Solve this. So I get 4 and 2. If I plug in a 4 squared minus 6 times 4 is 16 minus 24, which is negative, so that doesn't work. If I look at the other side here, this is a negative 8. There's not even anywhere to plug my 4 in. If you notice this from the very beginning, that this is a negative number, automatically the equation's bad. If you don't notice it, it's okay, because once you plug in your solutions, you'll find out that neither of them work. So this one is a no solution. Okay, go ahead and pause your video again. Try these few problems here. And then check back for the answers, please. Number 1, there's a single log in the equation, so we're going to put it into exponential form. So log base 6 of 216, so you're going to go 6 to the 3x equals 216. So now I have an exponential equation where I can write both sides in the same base. So I have 6 to the 3x equals 6 to the third. 3x equals 3. Therefore, x equals 1. Again, number 2, 1 log in your equation, so you're going to put it in exponential form. 3 to the x minus 4 equals 243. So if you can rewrite 243 as 3 to some power, then you're good. 243 is 3 to the 5th. So our bases are the same. X minus 4 equals 5. So x equals 9. Number 3, single log, go into exponential form. 4 to the 5th equals 4x minus 20. This one, we're just going to go ahead and solve. 4 to the 5th is 1024. Add your 20 to both sides. And divide by 4. So these bottom ones, or the second row here, all of these are log equal to a log. So you can just cross your logs off. Switch colors. 3 minus x equals 5x minus 15. I'm going kind of quickly, but you should have already tried these. Okay, cross your logs off. Here's a quadratic. So we should get x equals negative 1/3 and x equals 1. And then our last one, single log in there. So x to the second power equals 5x. Still quadratic. X squared minus 5x equals 0. You want to factor it. I know you might be tempted to divide both sides by x, but don't do that because you'll eliminate one of your solutions. Let's factor an x out. So we get x equals 0 and x equals 5. Okay, and if you go through and you check your answers, if we go back to number 4, let's go back and check. So if you look at number 4, we get x equals 3. 3 minus 3 is 0. So that's not going to work because you can't take the log of 0. And then 5 times 3 is 15, minus 15 is 0. So since that doesn't work, this is a no solution. Okay, go to number 5. If we put a 4 in here and here into the here and here, whoops, here and here, we're good. It stays positive. Negative 1/3, you're going to square it, it goes positive, so we're good there. And then negative 1/3. That number is still less than 1. It's negative 2/3, so that's going to stay positive. And then the 1 works as well. So both of those are our answer. Those both work. Check your 13. That works. For number 8, 5 minus 0 is 5, so that works. And then for number 9, if you plug your 0 in right here, you get a 0. Can't take the log of 0, so this is extraneous. So this is going to be my answer. So make sure you're going through and checking. So if you just solved those and didn't go back and check, you would have been missed a couple of the extraneous solutions. So, all right, that's the lesson. If you guys have any questions, let me know. I'm attaching a practice sheet for you. So do your best. Email me with any questions. See ya.